Hello, everyone. Thank you for being here. My name is Adam. I'm an Android developer as well. So a lot of what I'm going to be talking about today is based on work that I did at my former company. So if you're one of the people that I used to work with and you're watching a recording of this at some point, hello. I don't expect you to be a Gradle expert to walk out of this with something that you can apply to your code base. We're going to actually go through a brief introduction to Gradle, so we're all on the same page as soon as we get started on the actual tips that you can use. All right, so a little background about the app that we did this on. It's a smallish app, really, 30 plus modules. So straight, you can see that we should have probably done better on that. I'm sorry, that shouldn't have happened. We have about 50 plus screens and 1,400 developers on that app. Your team doesn't really need to be big for this to apply to you, but it certainly helps you scale as soon as you apply a lot of this. What we're going to be talking about today is, like I said, a brief intro to Gradle, some things that we just need to understand to move forward, the state of our build setup when we started doing this, some easy wins that you can do on your code base, and some general advice and best practices for your build scripts. Our build setup now, and what's most important, I think, is at the end we'll talk about measuring and how you can make sure that all the changes that you make are actually positively impacting your code base and not causing any regressions. All right, so the first thing we're going to be talking about is tasks. And then we'll move on to projects or modules, as we're all familiar with, and plugins, and the Gradle lifecycle. Tasks in Gradle are basic units of work. So everything in Gradle is ultimately a task. Everything you see, everything you do is a task. So whenever you, go to your command line and do Gradle W assemble debug, what you're doing is using a task that assembles the debug version of your app. Tasks can have dependencies on other tasks, so they wouldn't run before the dependencies are run. And you can also define default tasks for your build, so you can do something. If you assign the assemble debug task as your default task, for example, you can just do something like Gradle W from the command line, and it'll assemble your debug version. All your builds are modeled as directed acyclic graphs of tasks. These tasks are wired and generated based on the dependencies of your tasks. So this is what a graph looks like. We can see that task A depends on task B and C. So if you were to ever go and trigger task A, Gradle will see that it needs to run task B and task C first. And to run task C, it'll run everything up the chain. But if a task doesn't have any dependencies, it'll be run immediately. Your tasks can have actions, inputs, and outputs. Actions are what your task can do. The inputs are the inputs it takes, and the outputs are the outputs it produces. Many tasks can be cacheable. You might have seen things like when you run your build, you might have seen labels like executed or up to date or from cache next to your task names in the command line. Executed means that a task has an action, and Gradle thought it should execute that action for this particular build. Up to date means that a task has inputs and outputs, but they didn't change, so Gradle didn't need to run it, and that's incremental builds in action. From cache means that your task it was run before, and the outputs were stored in cache, so Gradle just pulled them out and didn't need to rerun it again. There's also skipped and no source. Both of them kind of mean the same thing. Gradle didn't run it, but for different reasons. This is how we'd go about defining a task in your build.gradle file if you were to do that. You might have seen a lot of examples online that use tasks.create. You shouldn't do that because that's an eager API. We'll talk about this soon, but this is the proper way to define a task in your build.gradle file. And if you wanted to write your task as code, I think this is more understandable. But more importantly, it allows you to actually say that your task is cacheable. So you can do this with the @cacheable task annotation right there. This is how you define your inputs. Inputs can be any different, like a lot of different types. They can be strings or directories or files. They can be iterables and a few more options as well. This is how you define your outputs. Outputs can be the same types as your inputs, except for strings and class paths. And this is where your work will actually happen. So you define a task action, and this is where you do the things that you want to do with your task. And then we'll talk about projects and modules. So all Gradle builds are made up of one or more projects. Remember how we said everything in Gradle is a task? Well, everything is also a project. So work that Gradle can do on any project is defined by one or more tasks within that project. And tasks are provided to your projects by applying plugins. You can write plugins on your own, or you can write tasks on your own as well. There's a great talk that you should have watched yesterday by Tony about authoring plugins. Some plugins that you're familiar with are KGP and AGP, and there's quite a few more. Plugins are essentially a collection of tasks that you apply to your project. So, for example, the Android Gradle plugin, AGP, is what makes your module an Android module. It adds all the things that Android that Android needs to know to build your project. And I think we skipped over this, but a project in Gradle is what we call a module. It's kind of the same thing. Plugins are used for configuring your projects via the tasks that they have within them. They're great for encapsulating repetitive logic. So if you've got something that you do all the time, it's a great place to start. Where you add these tasks to a plugin, and you can apply them to your modules. A famous plugin, like I said, is the Android Gradle plugin. So this is when you add this to your build.gradle file, what you're doing is adding the AGP. All right. The Gradle lifecycle is a lot easier than the Android lifecycle that we're used to. It just has 3 phases. The first phase is the initialization phase. During this phase, Gradle determines which projects are going to take part of this in this build, and it creates a project instance for each one of them. The settings file is also executed during this phase. The setting file, you might be familiar with your settings file. It's the settings.gradle file. Most people use that to sort of apply project-wide definitions. You add your class, you can add project-wide plugins there, and they'll be available for everything. A multi-module project needs to have a settings file, because it's where you actually define your different modules, and that's how Gradle knows how to aggregate them together. The second phase is the configuration phase. Like the name suggests, this is where your project objects are configured. All your build scripts that are part of this particular build are evaluated, which means downloading your dependencies, downloading the plugins that you added to your build scripts. So this takes a lot of time, and this is where we're going to be focusing on. This is where you need to spend as little time as possible. By default, the configuration of all projects happens before any task is executed. So whenever you execute any task, Gradle will try to configure all the projects in all the modules in your project. It's kind of, that sounds excessive, but it's kind of good for Gradle because it allows you to access all your projects at any point in time. And then we've got the execution phase of the life cycle. This is where Gradle actually executes all the work that needs to be done that was configured before. All right, the state of our build setup. So this is what we started with. Our build times were taken about 14 minutes on average for incremental builds, for our local builds. We had a lot of code duplication. So one thing that we had is whenever people wanted to create new modules, they'd go into the modules that were created before, and they'd just copy their build.gradle files and paste them elsewhere. This wasn't great because it meant that, for example, if we had a module that needed to be I don't know, a pure Kotlin or pure Java module, and people just copied AGP, that kind of invalidated that. So now you got plugins that you don't need, they're adding time to your configuration phase. Plugins are really expensive. So for example, capped, KAPT, even if you're not actually using it in a module and you're just applying it, it adds time to your configuration phase. All plugins are just expensive, so be very judicious about adding them. We also had work that was done repetitively and needlessly. If we had a task that was downloading something from the internet for a module because that module needed it, we actually had people copying that code, and that task would download that same thing all over again every single time for every module that was configured. That's not great. A lot of outdated tooling dependencies. We're going to be talking about this, but one thing that I should mention here is you should always try to update your tools. Tooling developers are just like you. They want you to use their newest versions of their tools just as much as you want people to use the latest versions of your app. They come with performance improvements and bug fixes, as we like to say. And yeah, plugins were applied needlessly everywhere, like I said. And we always created tasks eagerly. We did a lot of our work eagerly in general, and that's something that you shouldn't do, and we'll talk about that as well. All right, so some easy wins. A lot of these are one-liners that you can apply today, and they'll be good for your code base mostly. File system watching. This is actually enabled by default as of Gradle 7. So that comes back to the point of updating your tools. Always try to be up to date there. But what does it do anyway? So in order for Gradle to sort of know what tasks it needs to execute, it needs to check if the inputs and outputs of every task have been changed. And if they've been changed, it re-executes them. And the way that it sort of understands this is the Gradle daemon stores information about all your tasks in memory. But the Gradle daemon sort of lives across a few builds, but it doesn't live forever. So at some point when it dies and you restart your work the following day or something, Gradle doesn't have that information about your tasks, and it will re-execute them even if it technically didn't need to. So file system watching is a new API from Gradle, and it lets the daemon sort of hook into the file system. So across reruns, and when you come back to your work the following day, for example, the daemon checks with the file system through this, and the system tells it, well, I don't know, these tasks did not change, so you don't need to rerun them, and that's good for you. Configuration on demand. This is an incubating feature, and I'm not sure, but I think it's going to die. Yeah. Yeah, it might die at some point, but the way that it works is, so configuration on demand means that Gradle will not try to configure all your projects and all your modules every single time. So like we said, for example, during the configuration phase, all modules in your project are configured every time you run a task. Configuration on demand sort of allows Gradle to not do that. So Gradle can skip work that doesn't need to be done. Enable parallel execution. This is also not enabled by default. It helps if your project is decoupled. It's also, I think, this is not enabled by default because it doesn't always work. But if your project is decoupled enough, it'll be good for you. As the name suggests, it allows Gradle to run different projects in parallel. Build caching is another one-liner that's not enabled by default, and you should definitely enable it so Gradle can do all that caching magic for you. Yeah, so general advice and best practices. I don't really like the best practices part of this, but I'm not sure what else to say. Some of these are not going to be necessarily related to your build times, but they'll be good for developer productivity in general. Yeah, so the first thing is be vigilant about adding new plugins to your projects. Like I said, plugins add time to your configuration phase, even if you don't really use them. So yeah, try to be mindful whenever you add a new plugin to your project. And things like, I've seen a lot of code where people use the all projects block and apply plugins to all their projects. First, like, don't do that. Don't do the all projects blog anyway. That's not good because it means one of your plugins knows about every other plugin in your code base. That's not good. You know, we talk a lot about having different modules in our app and having these modules sort of be self-contained and making sure that they don't know about every other module. And it's the same for Gradle. You don't want one module to be able to configure every other module. That's not good. Some plugins allow you to disable them on debug builds. So for example, if you use the Firebase performance monitoring plugin, it's quite expensive to run on your debug builds, and you're kind of actually, like, you're not using it on your debug builds. So there's a small snippet here. This is straight from the docs. You can do this, and it will disable it on your debug builds. We saw massive improvements just from doing this. Replace KAPT with KSP wherever possible. I'm sure we're all familiar with KSP at this point. It's been all the rage for a while. Some of the libraries that we use right now are already supported, but so Room and Moshi are already compatible, but Dagger is not. But there are alternatives for this as well. So one thing you can look into is Anvil. Anvil is a really, really great tool by Square, and I'm not going to talk about it because other people have, but one thing that's really good about this library is they have one cool feature that you can adopt even if you don't use anything else from that library is their own Dagger factory generation. So what they do is they generate all the code for fields and classes and methods in your code base that have the add inject and add provides annotation. Instead of relying on KAPT to do that. And it's a plugin, it's a compiler plugin as far as I know. So effectively this means you can skip KAPT entirely from your build. It also generates Kotlin code instead of Java code, so that means your Gradle can skip the Java compilation task for every module where you have Anvil enabled. So that's one way to effectively remove CAPT, I think, if these are all the tools that you use that rely on it. And I think for the most part, these are all the tools that everyone uses that rely on it. Dagger Reflect is a tool by Jake Warden, and it's a reflection-based implementation of Dagger. So if you don't want to use Anvil, you can use that. But it hasn't been updated in a while, so I'm not really sure if you should use it at this point. Just use Anvil. Modularize. Of course, like I said in the beginning, we only started with about 30 plus modules. We could have done better. You can do better, but also don't do that needlessly. Modularization comes with costs. You don't want your graph to be so deep that for every change you make in a module, it ripples throughout all your code base. So also be mindful when you do that. One of the things that you need to think about, for example, is not every module needs to be an Android module. The AGP plugin is expensive. If you don't need it, if you have a module that's only for, I don't know, your data classes, your modules, or it's only for analytics or whatever, try to have as many of these as possible, honestly. Try to make a lot of your modules not dependent on Android as much as you can. Favor implementation configurations over API configuration for adding dependencies. The way this works is when you use implementation to add a dependency to your project, it's added to your project, but it's not added to the class path of your project, so it's not exposed to dependencies on your project. So if you have a base module somewhere, and I don't know, if you have a network module, for example, and it uses retrofit, because everyone uses retrofit. If you add retrofit as an API implementation and you change, and retrofit gets updated at some point, and so your module that depends on it will get recompiled, but every module that depends on it, if you're using API, will get recompiled as well. But if you're using implementation, that's not going to happen because it's contained within that module. So this is good because it means that Gradle can skip configuring a lot of your modules if you're judicious about how you expose dependencies on their class path. Everything gets added to your class path, so yeah, lots of problems come from that. Yeah, do as little as computation as possible during the configuration phase. This means you should favor lazy APIs when doing only Gradle work. So for example, if you're creating a task, don't do tasks.create. That's an eager API, and it should be deprecated at some point, hopefully. Yeah, don't do that. Use lazy APIs. I think there will be a link somewhere here to a page on the Gradle docs where it has all the lazy APIs and their better alternatives. The eager APIs and their eager alternatives. Yeah, favor writing your own custom tasks over scripts. They're a lot more readable, and they are more like you can more easily say that they're cacheable because you just add the add cacheable task annotation to them, and that signals to Gradle that it can cache the work from that task. But also, not all tasks can be cacheable. Some tasks are just really easy to rerun. They're not expensive. So tasks that do I/O work, like copying, jarring, or zipping, you don't really need to cache those. It's often faster to just rerun them on modern devices. Non-stable inputs can make cache hits difficult. So what that means is if your task takes inputs like a GitHub SHA or a commit ID or something, that makes it extremely difficult to cache that because these things change. So don't try to cache it because it's kind of needless. Unnecessary, sorry. And yeah, prefer lazy APIs over eager ones. So this is an example that I've mentioned before, using tasks.register to create your task instead of tasks.create. The difference between this is the task on the right is going to add 2 seconds to your configuration time, to your configuration phase. And that will happen every single time you configure a project. It'll be run and it'll add 2 seconds to your build time in general. Whereas if you register it, Gradle understands that it doesn't need to configure this task immediately unless you actually call it by name, and that's where those 2 seconds will happen. One other thing you can do is enabling non-transitive R classes. This comes with the caveat that I've seen a lot of people say it didn't really work, like it didn't really improve their build times, but it's good in the sense that it kind of makes your R classes contained within one module. So it's, yeah. If you look this up on Twitter, there are people that used it and they reported positive changes, and people that used it that said it didn't work for them. So yeah, do with that what you will. Disable the Jetafire tool. We also had that enabled for the longest time, but we didn't need it. The Jetafire tool, what it does is it replaces all the Android.support libraries in your project with their Android X counterparts. But that's quite expensive because it also adds a lot of time to your configuration phase, and it has to do that every single time, I think. I'm not really sure, actually. All right. But yeah, if you don't need it, disable it. And if you have any dependencies that still use Android.support, I'd honestly just reach out to their maintainers. They shouldn't be doing that anymore. Disable build variants that are not relevant to your build. So you're probably familiar with when you when you define your build types and for your project, so you can have your debug and your release versions, and you can have demo versions and versions that work with specific APIs and all that. What happens is Gradle creates a matrix of all of these different build variants, and it creates them every single time, I think. So if there are any variants that you don't use, disable them. So this is also straight from the docs. So what this does is it checks if you have any flavors, if the variant builder sees any flavors that use API and min API, their min API is 21 and their mode is demo. So if that's a demo build that uses min API 21. If you don't really need that, just don't build it. Don't use build source. Build source sounds like a great idea in practice, and it was all the rage for the longest time. It's good because it kind of solves a lot of the problems that we've been talking about in terms of code duplication and having one centralized place for you to define all your build logic. But the problem with it is that it gets added to your class path, which means that every time you make any changes in it, it validates your caches for the entire build. So don't do that. Use included builds or convention plugins, as I think the two terms are interchangeable, I think. Use convention plugins instead. And we'll talk about these at some point, I think. Use version catalogs and type-safe project accessors for easier dependency management. This is not necessarily going to help your build speed, but it'll definitely help with productivity. Type-safe project accessors are incubating right now, but we've enabled them for a while. They work fine for us. The way that they work kind of similar to version catalogs in that they generate type-safe accesses to your project module, to your project dependencies. So instead of, if you have a library analytics module, the way that we usually add these implementations is that you need to remember the string name, the string qualifier to that module. That's error prone because if you were to change it, you have to change it in so many other places, and you could forget. So the way this works is it generates these things for you, and if you were to ever change the name of that module, you'll get a compile time exception. So that's, yeah, it guides you towards where you need to update your accessors. Enable configuration caching. This is a really cool new feature because you might have noticed that a lot of what we've been talking about is things that happen during your configuration phase and how we want to do as little work as possible during that. Configuration caching is a new feature from Gradle that caches that entire phase. It's still an incubating feature, but it works really well. We've been using it for a while. Yeah, it's pretty stable right now, I think, but it's not actually stable from Gradle, but yeah, it's almost there. I think they plan to make it stable by the end of the year. If you look it up on Twitter, you'll see so many people raving about it. So this is, yeah, Tony, this is at Square. We can, yeah, just pausing if you want to read that. And this is Zach from Slack, also enabled it, and that's what they saw. Yeah. Another thing is, so the way that I see incremental compilation used to work on Gradle with Kotlin, sorry, the Kotlin incremental compilation used to work for the longest time is if you had a pure Java module, it wouldn't take part in your IC in IC because Kotlin didn't recognize it as a Kotlin module, so it would never create caches for it. And the way to fix this was to add an empty Kotlin file to your Java-only modules, so Kotlin would recognize that it's there, and it would sort of make it participate in the IC. You don't need to do that anymore as of Kotlin 1.7. They have a new, they've rewritten their incremental compilation, and you can enable that. It's still an incubating feature as well, but you can enable it if you want using this. And if you do that, you no longer need to add empty Kotlin files to your Java modules to make them participate in IC. Disable build config generations for modules that don't need it. This is enabled by default. So the build config file is a Java object that has descriptors for your project, like your main API, the project name, whether it's a debug version or not. That's what most people use it for the most part. But it's expensive to generate for all your modules, and if you don't need it, just disable it. And you can opt into generating it for specific modules that need it. So your app module, for example, if you need it there to check if you're on a debug version or not, you can opt into that for that specific module that needs it. In fact, you can actually opt out of many things that Android enables by default if you don't need them. So this is a list of things that you can either enable or disable, based on your needs. If you don't use them, just disable all these build features. All right, so onto our build setup now. After doing a lot of these things, we went down from 14 minutes for incremental changes down to about 2 minutes. And once we switched to M1 MacBooks, we actually, that was slashed by 50%. So maybe don't do any of that and just buy M1 MacBooks for everyone. We now use convention plugins to reuse and contain our build logic. I want to talk a little bit more about this because we kind of just talked about it very briefly. Convention plugins are in the same way that we think about creating modules in our build to contain logic that we can reuse everywhere. Convention plugins are sort of Gradle's way of doing that. So you can create convention plugins, for example, that define an Android module. Your convention plugin for that would add the AGP plugin. It would configure your Android block, like adding your min SDK, target SDK, all these things. And instead of having to do that work for every different module that you add, you can just apply your plugin. So you end up with very, very lean build scripts. So in an ideal world, I think what your build script for every, like your build.gradle file for every module that you add should look something like this. A plugins block where you add, so this is a convention plugin that we built internally, and it says, this is an Android feature plugin. And just by adding that, it adds all the wiring that you need to do on your own, but it's done in one place. So if you ever need to change it, you can just go back there. And it means that feature teams, feature developers, they don't really need to worry about this. They don't need to copy and paste it. They don't need to repeat any code that they are afraid of or they don't understand. And yeah, so you'd have your plugins and some convention that you need to apply. So namespaces are, it's just literally the package name of that module and the dependencies that this specific module needs. I think this is ideally what every build.gradle file should look like in your feature modules. I want to just briefly talk about measuring. One thing that I did is when I started doing this work, I didn't measure anything initially, and at some point the build times were reduced by like 6 minutes, and I had no idea what I did. So don't do that. Measure from the start, because you want to understand. You want to have preferably historical data to understand whether your changes are reducing your build times or making them worse. So one thing that you can do is the Gradle profiler. You can use that. You can run that manually if you wanted, or you can automate it somehow. I haven't actually looked into that. We ran the Gradle profiler a lot to sort of, so after every change, I ran that to see whether my changes made positive or negative impacts. You can use Gradle Enterprise. Gradle Enterprise gives you these really, really nice build scans that tell you a lot of information about your builds. So it tells you what tests are taking too long. If your tests are flaky, it tells you, it's just an awesome tool. If you've ever used --scan, that's what it produces. So yeah, look into that. But one other thing you can do is you can kind of write a poor man's build life cycle listener. This is not great. And I think it uses, what we did uses internal APIs that, we shouldn't have done, but because we couldn't get a Gradle Enterprise at my company, that's kind of what we did internally. So this is a very small sample of that. So you add a build life cycle listener. It gets notified when your build finishes, and you can do anything with that result. And you add it as a plugin to your project. And I'm actually I've ran really, really early. I thought this would take longer. But yeah, thank you.